Let's put the correct numbers from 1 to 3 in the boxes according to the rules. The number inside a block surrounded by a thick line equals the sum of all the numbers in the boxes included in that block. The numbers 1, 2, and 3 must go into every row and column exactly once. The exact same number cannot go into the same row or column more than once. Block sum deduction is just a tool. The real goal of this lesson is not the skill of solving problems, but developing relational thinking through a logical process of deduction. In block sum deduction, the value of one cell isn't determined alone. It's determined within its relationship with the same row, same column, block sums, and already filled cells. This structure is the optimal tool for training relational thinking. Through this lesson, children will learn to think not about what this is, but how this is connected to that. Read the rules and ask questions if there is any part you don't understand. Before explaining the rules, let the child naturally experience a moment of bewilderment when facing the problem for the first time. It is normal to feel that it's difficult, and you want them to feel that working through that difficulty together is the fun part of the lesson. Now, someone has solved a problem here. If there is a part that does not fit the rules, find it and tell me why you think so.
The first line is wrong.
If you mean the first line, are you talking about here? It has 1, 2, and 3 in it, so it looks fine to me. You even correctly filled the block with a sum of 3, since 1 plus 2 is 3.
No, not there. The first line with 1, 3, and 1.
If you just say the first line, we can't tell if it's the first vertical line or the first horizontal line. Please tell me clearly whether it is a vertical line or a horizontal line.
The first vertical line is wrong.
If we call both horizontal and vertical directions lines, we can't tell them apart. And if we add the direction name, it gets too long. Wouldn't it be nice to call horizontal and vertical lines by different names? We have such names ready. Those names are actually in the rules.
It's row and column. Which of these is the name for the horizontal line?
We call the horizontal line a row, and the vertical line a column. How many rows and columns is this problem made of?
3 rows and 3 columns.
Now, where did you say you found a mistake?
It's column 1. 1, 2, and 3 should go in once each. But there are 2 1s and no 2.
That's right. When 1 is used twice like this, we call it a duplicate. And when 2 is left out, we call it missing. Aren't these cool detective words? Now look for another line that has a duplicate or is missing a number.
Column 2. 2 is a duplicate. Row 3 is also wrong. Because 1 is a duplicate.
I see another problem in row 3 as well.
There's a 4. It said 1, 2, and 3 must go into a line once each. 4 cannot go into this table.
Finding errors is a way to check if they understand the rules, but more importantly, it is the first step in developing an eye for verifying relationships. Please help the child understand that the number in each cell does not exist on its own, but its correctness is determined by its relationship with the row, column, and block. The child has learned the names row and column, but doesn't yet have the language to point to a specific cell. Introducing coordinate language, row and column, in this process is not just a simple technical drill. Deduction happens through language, and accurate deduction is only possible when you have precise language. Do not rush this process. Good. You understood the rules of block sum deduction well. Now try solving the problem. Which box did you figure out first?
I started from here.
Where is here?
The third box.
Here? Or here?
No, not there, here.
Can't you tell me exactly instead of using the expression here?
Since it's the first horizontal line, row 1. The third box in row 1.
Looking at the horizontal lines, it's the first line. How is it looking at the vertical lines?
It's the third line. So it's column 3.
That's right. So we can call this box row 1, column 3. And we simply write it as 1, 3.
That's really simple. I almost lost all my energy trying to say which box it was.
Now, let's practice. When I point to a box, tell me its name. This is the section where the core algorithm of this lesson appears. Do not give away the principle of starting with the fewest possible cases up front. It is crucial to let the child discover it themselves through trial and error. Even if they go down the wrong path, that in itself is learning. Good. Can you tell me again where you started solving?
I started from 1, 3.
Why did you start there?
Because the clue says adding it with 2, 3 makes 5.
So you're going to use the relationship between 1, 3 and 2, 3. So, did you figure out the number that goes into 1, 3?
Since 2 plus 3 is 5, it's either 2 or 3.
There are 2 possible numbers. What should we do?
I tried putting in 2 first.
So you're saying you'll put in 2, and if that doesn't work, you'll try putting in 3 again. Isn't that a lot of extra work? Is it really a good idea to start figuring it out from this box?
The boxes that gave us the sum are 1, 3 and 2, 3. So I think it's right to start from there.
I understand. Then fill in the boxes both ways as you said. Compare the 2 tables.
Huh? In both ways, 3, 3 is exactly 1.
That's right. 1, 3 and 2, 3 have 2 possible numbers, but 3, 3 has only 1. If so, shouldn't you have figured out 3, 3 first?
It's strange. They didn't give us any information about 3, 3.
It seems that way if you only look at that box.
Where else should I look besides that box?
Here, you can't figure out one box all by itself. You have to look together at the boxes connected to 3, 3.
Now I get it. You mean look together with the other two boxes in column 3, right? 1, 2, and 3 go into column 3 once each. And since 2 and 3 go into the top two boxes, the remaining number 1 has to go into the third box.
Very well done. Let's think about it a little differently. Here is column 3 with no information at all. If it's column 3 with no information, how many ways are there to fill in 1, 2, and 3? Let's find them one by one. Compare the 6 ways. What is the difference?
That the positions of the numbers are different.
What do they have in common?
That 1, 2, and 3 each go in once.
There is something they have in common that occurs because 1, 2, and 3 go in exactly once.
The sum is the same.
That's right. Do you also know what the sum is?
1 plus 2 plus 3 is 6.
Good job! Now, what is the sum of column 3?
It's 6.
How do you know?
Because 1, 2, and 3 each go in once.
By any chance, do you know what the sum of row 2 is?
Of course it's 6. It's the same. 1, 2, and 3 each go in once.
We use sum information to solve the problem. And for this problem, they didn't just give us 2 sums, 8 and 5. Even without being told, we had a hidden clue we figured out through the rules, right?
6? The sum of every line is 6.
Good. Keep in mind that the sum of a line is 6, and look at the problem again. Looking at column 3, we didn't just know that the sum of 2 boxes is 5.
The sum of a line is 6.
It means the sum of 3 boxes is 6. And the sum of 2 of them is 5.
Then the remaining box is 1.
Can you tell me your answer first and add a because at the end to explain why you think so?
3, 3 is 1. Because the sum of the 3 boxes in column 3 is 6. And since the sum of 2 of them is 5, 6 minus 5 is 1.
There are 3 boxes where you can't see inside. We are going to divide 6 candies into these. If there are 4 candies in boxes 1 and 2, now, how many candies are in box 1?
It could be 1, it could be 2, or it could be 3.
That's right. There are several ways. But there is one box where we know exactly how many candies are inside.
Box 3.
How many and why do you think so?
There are 2 in box 3. Out of the 6 candies, 4 are in the first 2 boxes.
Can you write it as a number sentence?
It's 6 minus 4 is 2.
The candy analogy is a bridge connecting abstract number sentences to everyday language. The moment the child realizes that the structure of block sum deduction and the structure of the candy boxes are the same, the relationship that subtracting a part from the whole gives you the remaining part becomes understood. Well done! We figured out that we need to solve 3, 3 first. Why?
Because there is only one number that can go into 3, 3.
How did you narrow it down to just one number for 3, 3?
Because we know the line sum. And we already know the numbers in the other boxes except for that one.
You figured it out by looking at how it's connected to the other boxes in column 3. Now, let's look for what we can find using the clue that the sum is 8.
Can we really figure anything out with this? If 4 boxes add up to 8, aren't there too many ways to make it?
Is there anything else you know besides the 4 boxes adding up to 8?
That the line sum is 6. So the sum of column 1 is 6. Wait.
We know the 4-box sum, and we know 3 of those boxes add up to 6. Did you find a box where we have fewer choices?
It's 1, 2.
Tell me your answer first, and add a because to explain the reason.
1, 2 is 2. Because the 4 boxes add up to 8, and the 3 boxes inside column 1 add up to 6. So 8 minus 6 is 2.
Look at the 2 number sentences. 1, 2 is 8 minus 6 is 2. And 3, 3 is 6 minus 5 is 1. Both have 6 in them. But can you see that the 6 is in a different place?
We subtracted 6, and we subtracted from 6.
In 8 minus 6 is 2. The line sum 6 was just a part. We subtracted the part 6 from the whole 8. But in 6 minus 5 is 1. The line sum 6 is the whole. We subtracted the part 5 from the whole 6. The line sum can be a part, or it can be a whole. Now let's fill in the remaining boxes. Remember the rule that 1, 2, and 3 go into a line exactly once?
1, 3 is 3. Because it could be 2 or 3. But if I put in 2, it overlaps with the 2 in 1, 2.
When you first looked at 1, 3, there were definitely 2 possible numbers. How can you decide on just one number now?
I first found 1, 2 which had only one possible number. And thanks to that number, the possible numbers for 1, 3 narrowed down too.
This is the moment the child experiences the chaining of deduction. What is found first becomes the clue for the next step. Let them articulate this flow. This is why the order is so important when finding answers with clues. What should we figure out first?
The boxes with the fewest possible numbers.
Let's figure out the remaining boxes too.
1, 1 is 1. Because the only number left in row 1 is 1. 2, 3 is 2. Because the only number left in column 3 is 2. 3, 1 is 2. Because 2 goes into either 2, 1 or 3, 1 in column 1. But if I put it in 2, 1, it overlaps with a 2 in 2, 3.